All right, thank you very much. So welcome again, everybody. For those of you joining us online, we've been waiting a little bit more because we're down in the basement of this massive hotel, and it's kind of hard to find a way to the room. So congratulations to all of you in the room. You've made it, right? This is the right place. Thank you all for coming. So just to set expectations right, what this BoF is about is not about me talking again. It's about getting inputs from you, from your experiences with respect to the topic of networking sustainability, your ideas, things that you might have tried, or problems you might be facing in whichever institution you're working in. So uh, I've prepared like a short click-through survey with a couple of questions to get an idea about who you are and to set the frame right for the discussion later on. And then I have three questions prepared for prompts for you and open my discussion. So that's meant to be mostly me learning from you and not the other way around. So with that, so here's the link. So if you prefer typing in, you have the short URL. If you're more like a QR code person, you can also scan that. I hope it's big enough. It should be more than big enough. So it's just, again, a couple of short click-through questions. You should not have anything to type, so it's also fine on your phone. Um, and I'll let I'll give you a couple of minutes to go through that. That, of course, is also very welcome to be filled by the remote attendees. Um, now, grab. So I'm sorry, it's going to go away for a short second because I need to bring this back first. Okay, there we go. All right. So this is the only time where you're making the presentation and you're happy everybody is looking at their phone. Yeah. This is what you're meant to do. Nice. It's kind of those moments where you hope to see some patterns in the data and it actually happens. Yeah. I will quickly show the overview in a couple of minutes with everybody. All right. So while other answers will keep popping in, I think it already allows to give some decent picture of the audience. So let me share the quick overview with you folks. So is that decently big enough? Yes. Okay. So most of you are working at ISPs, which is what I kind of suspected, but not all of you, right? Is sustainability a concern? Well, for most of you, it is minor to major. Uh, that's the first step, right? Caring is what we need right now. Now, the next questions were about: are you measuring the energy usage or the carbon footprint? Again, I was kind of suspecting that a lot more people will be measuring energy than carbon, and there's a good reason for that. It's a lot easier to measure energy because as of today, that's the only thing you have to pay for. So typically, people care about what they have to pay for. But there's still some people that either don't know or say that not really measure those things. And that's one of the hurdles that we are facing in our research is that people don't really know what they should be looking at. Some aspects I hope to discuss a bit tonight. So, but then the real question I have is, if not, why not, right? So I've set up suggestions. No business incentive is what I suspected to be the most commonly replied answer, and that seems to be the case. And then the second half was about what do you do in order to improve? You know, measuring is step one. Improving is what really matters at the end of the day. And again, it's much harder to improve rather than measure. And we can see that in the data. So what I was kind of interested is like, okay, assume we can improve on carbon or energy, how much performance degradation are we willing to tolerate, right? And so 1%, well, most of you say, okay, if there's 1% better, I don't want to have any degradation, which is not surprising. At the other extreme, if we can cut by 50%, you know, it makes a bit more performance degradation tolerable. So I think this is kind of what I was hoping to see, that we need to explore that space of trade-off. How much can we really achieve? How much reduction can we really achieve? Honest answer is I don't know. Nobody really knows. But the research that we are trying to do, and the reason I'm here today is to try to get a better understanding of what trade-off are realistic and what people are willing to try. Because if I'm saying maybe we can save 50% and you're still replying like, sure, but I don't want any other performance degradation, it's going to get tricky. But as I hoped, I think we can find a decent trade-off between traditional performance metric and sustainability related metrics like power usage and corporate footprint. All right. Um, I'll share to the extent possible those results to whoever is interested later on. We'll see with the right folks if that can be shared somewhat on the program. Now, as I mentioned in the introduction, that's kind of like the end of me and the beginning of you. I have three questions that I thought would be interesting to discuss during this 45 minutes we have left together. So I will run through the three questions, so just you have an idea about the topics I would like to bring up, and then I would very much welcome everybody's contribution, both in the room and online. So the three questions are the following. First, what issues do you or did you face in your institution with respect to sustainability? What are the key problems or the major hurdles that you're trying to overcome? The second is, what have you tried? Or what have you implemented and are effectively running as practices to improve on sustainability aspects in your network or in your institution? And lastly, what good or bad experiences do you have with respect to academic and industry collaborations? Because at the end of the day, as you got the picture, that's why I'm here. I'm trying to make this collaboration happen and to make them as successful as possible. So I'm still fresh at this game, so every insight and experiences would be interesting to share. All right. So let's go back to the first question. And now is the time where I will very much welcome any input from your side. That doesn't seem to be on yet. So hopefully we'll get there. Yep, something's happening.
Stefan from Open7. Um, I have a total different opinion on this.
Sure.
Not destroying your ideas here, but I've seen more problems in software, in Kubernetes, in virtualization, where the software really sucks and really is 5 times as big as it should be, and that there's much, much more you can do with better software than you can actually can do with optimizing the network. And the problem is that all the things you have presented, in my opinion, does not show. Maybe you have done it, but you have not presented it. Does not have shown any cascading effects you have. Mm-hmm. And problematic thing in networks is that if you start at one end to play around, you have had the example with switch it off for a second. So, but that means the next hop switches also off for a second, and the next one, even if it's 100 milliseconds and you have 10 hops, it's a second. And these effects really have impact in the network. So, and these effects you cannot actually can maybe control inside your own network, but you cannot control it over your network border. On the other side, if people use the same concept, you can break a whole data center with this. And therefore, I think focus better on more efficient software development on the server side than on the network side.
Thanks for the input.
Maria, developer of BERT. Well, I'd like to say that yes, we are on shame for this. Does it work? I'm just too far. Oh, sorry. Now it's better. So we are also on shame on this. We are still having BERT2 only one single threaded, which means that if you want to run an IXP, you have to buy a computer which has the fastest CPU regarding one thread performance. And it's a really challenging task, especially for our biggest customers. So this is why we are developing multi-threaded version, and it's fucking hard.
I believe that.
I must say, it's BERT has been created by 3 geniuses. These were hyper-optimizing BERT in a single-threaded world for a single-threaded execution. And we have to unoptimize those things to make them even possible to multi-thread. So yes, there are problems in sustainability with software. Also look at web browsers, look at your Thunderbird, at your Outlook, look at how much the memory consumption and how much the CPU consumption goes up. This is a real concern, and I would say if we could use a CPU with not 40 cores but 20 cores, maybe it would save a lot of energy and also a lot of silicon itself, which is adding another layer. We are just buying the hardware. We are having a server doing almost nothing in the server room because it's running just performance tests when we need it. But we need it. We need it to have it there and to run it when we need it. So there is another thing with the material itself, and I am specifically pointing on lifecycle assessments, which can then bring other questions like whether the running costs are really of a concern, or whether the manufacturing costs are of a concern, and whether it's worth it to have 3 nanometer technology over 7 nanometer technology over another, and so on and so on.
Thank you.
Sebastian Becker, Deutsche Telekom. I would like to agree to both of my previous speakers to that, and would like to add some of the issues we saw in our network about that. Because yes, we thought about, we have a highly redundant network where we basically can say, okay, most of the time less than 50% is utilized, because of we need to ensure that it should work all the time with a single failure environment. But if we think about switching off half of it for what time ever, if you need it and bring it up and it doesn't work anymore, this is basically the biggest problem, because with turning that off, you lose the complete monitoring of your links, of your line cards, of your routers at all. And it will just happen in the moment you bring them up again. And we do know out of the past that power cycling of things are more problematic than just let them run.
So just as a side comment, if you have concrete experience reports or data for those things, it would be extremely interesting for us to have a look at it. Just saying about. Okay.
Hello, Lorenzo Moro from Topics. We are a small internet exchange in the northwest of Italy. Well, to address this theme, I would put the accent on the fact that we had better somehow reasoning about demystifying edge, going to the edge, because that's a huge concern about sustainability with regards to energy efficiency. Since we actually run an internet exchange which is distributed, so we have bigger POPs in larger scale data centers, which are quite efficient from the energy point of view and the conditioning and so on and so forth. But when we're going to the edge and, for instance, delivering our service in local communities which are widespread across the valleys, so, to overcome the digital divide, then you have to face, shelters along the motorways, mold boxes, and so on and so forth, which is far a good, effective way of delivering your network, your service, and let people connect to the internet, to wider band. But at the same time, you have a huge waste of resources, conditioning those, because they're not efficient at all. So the narrative speech of going to the edge somehow conflicts with the idea of being sustainable. And that's one of our concerns we have to face. So that's a point of reasoning about it.
Yes. Oh, yeah. Yes, please.
Hi, this is Anand from RIPE NCC. We have someone asking remotely.
Yes.
Vesna Manojlovic. And she is replying to this question about what issues. Her question is the unclarity of the difference between the impact of hosting your own services versus outsourcing both the services and the energy consumption to the cloud. So
I know this is like a real question mark in research, and there are some countries in Europe, in particular in Ireland, that there are a lot of discussion where going away from, there are some people advocating for stopping to outsource everything to public clouds, and because it turns out to be a lot more effective to run on small scale on-premises clouds if they are managed the right way. I'm not at all an expert in this area, so I don't have any insight on whether this is a good or bad idea. I just know that some people are indeed talking about this, and of course, I guess the question, as always, is going to be, it depends on the type of network and the type of services you're trying to serve. But I know some people are looking into this, and that's a question mark as well. Sure.
Like with Zero. So a good response to that question is ask your cloud provider for the total scope 3 emissions, scope 1, 2, and 3 emissions profile of the product that you're renting versus your own impact with whatever colo and stuff you're running. Chances are, so enterprise IT is like the least efficient way possible to do computing. So unless you are doing, you may be hosting your own stuff, but unless you have like a processor that has come out in the last 2 years and has more than, let's say 48 cores or something, you know, you're talking about 2-3 watts per core max. You know, if whatever thing that you're hosting your stuff on uses more than a couple of watts per core, it's probably more efficient to run it on a commercial cloud, because their primary input, their primary economic input is electricity, right? That's what it's just parts and electricity. That's what determines how expensive the commercial cloud is.
Yep. So just I don't expect everybody to be familiar with emission scopes. Scopes 1, 2, and 3, like who knows what this is about that our colleague talked about? Yeah, 2 shy hands. Okay. So in a nutshell, to be very, very short, so scope that refers to the classification of carbon emissions. It's a way of measuring and attributing carbon costs to different parts of the life cycle of a product. And in a nutshell, the easy way of thinking about it is scope 1 is the carbon that you emit yourself by burning fuel on your premise. The scope 2 is the carbon emission related to the electricity you buy in order to do stuff. And scope 3 is all the rest. Right? So scope 3 are the emissions from your supply chain and your customers. Right? So, and I think it's a very good point to encourage for more information as a user for the cost of the service you're buying. But it needs to be understood that coming up with those numbers is far from trivial, and the academic community around this is far from reaching a consensus of the right way of doing it. But that's work in progress by some of my colleagues. Yep.
Yes, hello. Michel with Lukix in Luxembourg, yet another small internet exchange. A data point I'd like to add is that in Luxembourg, I know for sure there is a mobile operator who's at night switching off frequency bands. Mm-hmm. So things can be done. Yep. It's been done to save energy. And however, it has side effects like location-based information that doesn't work anymore. People are located suddenly at a completely different place that they really are. Mm-hmm. So yes, can be done, but there are side effects. I think that goes for anything that you do. Yes. We've discussed already some of them. Then another point, when you look at the life cycle of equipment, I mean, we already, well, you had a question earlier about the trade-off between the running cost or running electricity, mm-hmm. and the CO2 footprint that goes into building something yes. new. So yes. should I continue running yes. my old stuff, or yes. should I buy something new, more efficient? Mm-hmm. It's not easy to do that trade-off. But if you want to continue running old equipment, and especially in the networks side, also servers, at one point in time, they go out of support. Yes. And then you're basically screwed. If it's only a question of hardware support, I mean, you can still continue. Easier. That's the easy side. Yeah, it's easy. Yes. But if it goes out of software support and suddenly you cannot fix it anymore, that's really where life stops. Yes. I mean, if you need to do bug fixing, security bug fixing, and so on, in commercial software, you cannot do it. Yeah. You cannot do it by yourself. I know. So you're screwed. I know. So I promised myself I will try not to respond to every comment. But this point was raised already multiple times today after my presentation, and it's very true. I prefer leave the floor to other people, and then we can discuss later. There is no easy solution. I mean, it has to be addressed to the vendors.
Yeah. Okay.
Throw away all the old boxes. There's a nice example how many people actually has used in the last 5 years. Still the 6500 from Cisco with 3 kilowatt, which actually can be replaced by a box with 90 watt. So throw away as fast as possible old equipment. Don't leave it in the data center. That has a huge impact because recycling is very good nowadays. It's better than 10 years before. It's not perfect, not saying it, yeah. But it's better. And the other thing is, I think we are blind on both eyes, or maybe a minimum of one eye, because if I spend in a, say, a solar panel on the roof of a data center money, and I supply my data center with the solar power on the roof, I think it has much bigger impact than to switch off any links on a system or on a network. The data center itself, they are sometimes pretty old, and it's not only the power of the box itself or the optics is using, it's actually also, you have to cool the stuff down.
Yeah, of course.
So I have heard from engineering here in Germany, I have not checked the source, but they say by optimizing the software which is used for the AC inside the data center, you can have a reduction from 30 to 70%. And look how much these engines suck. So why we are talking about network equipment, if actually the data center itself is maybe a better target. And the second thing is private home. I've seen your presentation where you have shown that private people at home, that this equipment does really suck a lot of electric power, especially if it's not needed. But most of the boxes I know CPE devices automatically can switch down, say, the gigabit ports or the bandwidth of the Wi-Fi.
Yes.
It's not always switched on. And most of these boxes, and maybe Sebastian corrects me here, but most of these boxes are actually remotely managed. So actually with the TR protocol, you could switch off in the night, save frequency bands or lower the output power, anything.
Yeah.
So there are other ways which are in a way really more effective than switching off optics.
So I have to shortly reply to this comment. First to say that I agree with what you're saying, and is most likely true. The second answer, and I had those slides in my presentation, I decided to cut them at the end. I think where I disagree with you is that you're opposing those two things as if we need to do one or the other, or we should rather spend our energy doing one or the other. I don't think this is correct. I think we should improve on all fronts. And the reason I'm here today to talk about networks is because first, that's what I somewhat know. And this is where I hope to bring my contribution.
It's honorable, your contribution here and what you try, but if there's an easier approach to say a number, to lower CO2 footprint by 50 to 80% doing A, and your approach lowering it by 1%,
yes.
What would you do first?
The thing is, like, I have 24 hours in my day, like everybody else. And I think I'm going to be slightly provocative here. I think with too many communities have run away from their own responsibility for too long by saying that other people were doing things worse. And it has to stop, right? Everybody needs to get the hands down and do their share. If our share as networking people is small, so be it. Let the software folks fix Kubernetes. I have no clue about this. It's like, I'm not going to say, okay, now I'm going to work on Kubernetes because they suck. It's like, I know networks. I'm going to try to do my share on networks. Shall that be small? It will be small. But this is what I know and what I can contribute. Your earlier comments about the domino effects is also very true. And what I was pitching earlier today about, turning links off.
So how expensive is the work? Sorry to interrupt you here.
Yep.
How much money do you earn in a year? Say 100,000 euros. And we now invest 100,000 euros in your research. And we get 1% CO2 footprint less. I take a guy from the AC community who writes a really fancy piece of software lowering 40% AC, and he's also 100,000.
Yeah.
You see, the question here is how much money you want to put on it. It's an economical question at the end of the day. And use the money you have, and it's a limited resource in CO2. I hope you don't disagree. There is not.
There's no infinite money.
There's really limited. So spend the money where it makes sense first. And I personally say it really does not make sense. It's from the academic point of view, I agree, it's a nice topic to discuss, but it has not really an impact.
Yeah. I think as pointed out earlier today, we'll need to agree to disagree and be fine with that.
Hello, I am Abdurrahman Abu Talib from Internet Society Yemen chapter.
Yep.
I am network engineer, but also I am activist and journalist specialized in environment. So this cross lines between technology and environment is very interested for me. Last month, I met Vinton Cerf, who's known as the father of the internet, and there was like.
Can you speak slightly closer to the mic?
Okay.
Thanks.
So I've met Vinton Cerf, and we have like a conversation about the sustainability, and he told us that he is working in Google. So the engineers there, they have like weeks of development about machine learning for their huge data centers. And they managed eventually to reduce the energy consuming by about 25%. So they reduce the consumption, and they reduce the emission of the carbon fingerprint. So how do you think using like get benefits from artificial intelligence in your research or in general to get benefits from this in big data centers and telecommunication? Thank you.
So I kind of have to reply. It's a tricky question. I have to say I'm really on the fence about the ever-growing use of AI tools, because on the one hand, it is a fantastic enabler for many things. On the other hand, it still have very serious computational costs, and I think it is a tool that should be used for the right purposes. What I'm not at ease with is that it's being used for anything right now, and that is kind of going out of hand, if you ask me. But that's really like a personal and not my researcher hat, because it's not an area I'm working in. I was just trying to look up again some data, because you were mentioning about Google and the improvement they made. Okay, I'll look for that later. But essentially what I wanted to show is that it is true that over 15 years since PoE was introduced, massive improvements have been made. But if you look at so everybody knows what a PoE is? It's essentially the ratio of how much energy you spend on useful work versus the rest. Right? So a PoE of 1 is like optimal, you spend 0 on cooling. Now, Google has achieved like an average PoE of something like 1.1. And they started at like 2.7. That means at 2.7, they're spending almost 3 times as much on cooling and the rest than on compute. Now, the problem is that there's an asymptote here. Like, and now what is left is like really, really hard to shave away, and we cannot keep improving the efficiency forever. And so if we keep scaling up the demand and we cannot improve the efficiency anymore, then, well, yes, please.
Maria, once again, I have 2 notes. First note, thank you for picking up such a controversial topic, because it clearly opened the discussion quite well. I must agree that it's a good topic for research, and also I must say it's a good topic to open a discussion to find out whether this is a good idea or something else is a good idea. I think, is there anybody who never went to a cul-de-sac and who never found out that the first approach was wrong? I had to throw out like years of my work while going to my goals. Well,
such is life.
Such is life. Yeah. Yes. And the second question, I'd like to point out that the industry is still missing some people who completely didn't go into the industry, just because the industry is marketed in many places like men only. Please, if you are concerned with those, come to the diversity working group. There are some issues which are very related to this, because we are missing the talents. Thank you.
Thanks for that. Yeah, I would like afterwards to move to the second question for at least a little bit of time, but yeah.
Hi, this is Anand again, and we have some questions and comments from remote participants.
Yes, please.
Sander Bauer of Greenleaf says, rather than the software and hardware, have any ISPs actually embraced the integral paradigm behind the Sustainable Development Goals, abbreviated to SDGs? A great deal of society is in utmost turmoil about what they can do at the private level, but big corporate players seem not fully on board. For example, and there's a link to a Wikipedia about nostalgia, and then he continues, I recently interviewed a big Dutch player in the field promoting their fiberglass, and this is a single aspect which they were going to do anyways to make a lot of money, whilst foregoing the adverse impacts of their social equity indicators.
So I'm not working in an ISP, so I don't have the answer to this question. But I think sustainability goes beyond energy and carbon. Like that needs to be said at some point, right? So there are a lot of other concerns to be had on this. And I'll be thrilled to learn more about great initiatives about this.
Just to respond to that one real quick, there is one called Interlink. There are people from them here today. I don't know if there's anybody in the room, but yeah.
Yes, please.
And there's a second comment and question from Rudolf Vandenberg.
Yes.
In his private capacity. He asks, in your opinion, is it better to run two redundant links of 2 times 100 gigabits per second or 2 times 400 gigabits per second when the latter is using less energy but has too much capacity?
So I'm smiling because we've had this conversation with Rudolf before, and my answer doesn't change. It really depends how much capacity do you actually need, and it depends how the system is being designed. As of today, if you scale up the transceiver, you will pay a power cost for this, and this power cost will be flat depending on the traffic you see. So loading the thing more or less will make no difference. What I'm internally convinced about, almost not. It's non-zero. Rudolf has been among the people arguing that it's so small that it should be assumed to be zero. What I believe is that if we're to rethink the software hardware co-design of network devices, this should not be true. We should be able to really reduce the power at low utilization mode. Until I've proved this, it will remain a conjecture. But I'm sure this can be done. And I'm trying to see what's the cost of making that happen, or if that's even possible. Maybe I'll be proven wrong, and maybe there will be a cul-de-sac, as mentioned before. But I think we should be trying.
Sebastian again. I like the point that everyone need to do something. And I see within an ISP running also a mobile network, a lot of things are tackled, like maybe switching off even cells that can be utilized by,
last
by
winter
the next
was done.
one. We can turn off one, but again, it goes against maybe certain things where you need that more local connectivity. Like if you look at future use cases where that really being to the edge for certain applications is very much needed. And as an ISP, basically there's a point in your question or your survey at the beginning is how much we can accept. And from our side, or what's expected from our side is exactly zero.
Nothing
of course. Less than you get. Mostly it's the other direction. We need it better. And that's obviously the friction we are in as an ISP, mobile provider, whatever. Blake was saying again, I know you're wanting to get on the next slide, but to respond to the
we're
question,
getting the reach answers, and that's great.
To respond to the question from that Anand had from the chat earlier. So there are two separate things there in that question. The first is if you just talk about the Ethernet system itself, 100 gig Ethernet doesn't actually mean anything. 400 doesn't mean anything. What we're talking about is if you compare systems from different generations, first gen 100 gig Ethernet was a 25 watt CFP
and
with
it's like
12 lanes
and it's like
on the
3 watts
motherboard
now.
and 10 optical lanes, and it used 25 watts. Guess what? First generation 400 gig can use up to 25 watts. Like that's just how this stuff works. So if you compare single lane 100 gig E, right? Yes, that's going to use less power. Is what we think of today as 100 gig E is like a typical LR4 CFP, QSFP28, sorry. Those are in the like 3 to 4 watt neighborhood, whereas a 400 gig optic uses maybe twice that much power for an equivalent kind of connection, sort of, maybe in the 8 watt neighborhood if you get a good one. But which brings me to my point of, as you scale the generations of the hardware, what you're looking at more and more is the efficiency of the whole system, the watts per gigabit or gigabits per watt that you are using in the entire machine, right? Because when you look at, say, 800 gig stuff, which you can now purchase from at least 2 vendors pretty soon, like 4, and even up to the 1.6 terabit Ethernet, what you actually have is an optical platform that just happens to have a big router chip behind it. But you know, if you look at the 800 gig 1U, 2U boxes, this is a box that has maybe 200-300 watts of like circuit components in it, and you can put a kilowatt of optics in the front of it. Right. So as you scale up the technology generations, the power used by whichever transceiver you select becomes a whole lot more important in the power factor than the actual like forwarding chip behind the box.
I totally agree. So that's something I did not explicitly say in my slide earlier, but in this power model, in this like F of the config bubble, is typically what type of transceiver you use. And that needs to be factored out because it's completely independent of the switch itself or the router. Like it has nothing to do with the way this hardware was designed, but the power needs to come from somewhere. And that's what's from the thing, which happens to be one key problem on the power supply dimensioning, because they tend to be outrageously over-dimensioned because of that. Because say, in theory, we could plug like 32 times 40 kilometers optical transceivers, which like nobody does. It makes no sense. Right.
And what we're seeing in a lot of equipment now is that they say, well, you know, this specific block of ports, those get the, like pigeon fire. You know,
it's getting better. It's getting better.
QSFPs, but these are like LAN ports.
It does get better. Also some newer devices that also a bit more forward-looking with us.
This is Rudolf van den Berg, again, continuing in his private capacity. His question, and then there's a comment. He asks, is energy proportionality more important or total energy consumption? And then he continues with a comment. I agree with Romain that we need to decrease energy consumption, though I think it can be done while increasing capacity.
Yes.
KPN decreased energy consumption by 45% in 10 years in absolute terms.
So for once, it's a very easy answer. What matters is not proportionality. What matters is total energy use. That's an easy one. So for once, I can be conclusive, right? Because this is what costs at the end of the day. How do we manage to deliver the service we need, you know, at minimal resource costs? And the resource is the energy in this case, or the carbon, which is not quite the same thing. So I'm clear on this. I think fostering energy proportionally would be a mean to reduce the energy costs. It's not the only one, just the one that I happen to be studying right now. I'm very open to be proven that this is indeed not the best approach and shift gear. And all those inputs are extremely useful for me today. So thanks a lot for that already. If that's fine, I would like to quickly shift to hear more about like the solution sort of side of things. If there are people in the room that have examples in mind of things they've tried and that they found to be effective, I would love to hear about them. Yes, please.
Not always to be first, Stefan from Open7. I think the most successful in the last 20 years was regular swap equipment every 5 years. And the second thing is talk to the optic vendors. It makes sense. There are new optics now which use 30 to 50% less power, which in two ways is good because normally if you have optics which use a lot of power, you cannot always put this, if you have 48 ports, you can sometimes only put 24 ports in.
Yes.
So it makes it inefficient. So
yeah.
half the power, half the heat, full chassis is good. And the second thing I've seen is we are getting rid of the chassis-based systems. I think they are oversized nowadays. I've seen very successful, and with my old company, we have done everything in rack space, so we can easily swap technology. So is this 10G access? This is pretty efficient, and we need 100G backbone. It's 400, so we swap the 100G box. And this can be from a
and
different
keep the
vendor.
rest.
And this is really, really successful. Don't stay with your old equipment. It's all interoperable. The interoperability of the protocols is pretty good nowadays. So take the best box you have with the least power consumption.
Yeah, Blake was there again. Yeah, our success story was just based on tying the technical debt to the power bill, right? We had all this old junk that we wanted to upgrade. There was no budget for it or whatever. Get the power bill from the data center operators and show, oh, look, this 15-year-old equipment uses 35 watts per 10 gig port, right? This brand new switch uses 70 watts for the whole thing, all 48 of them.
Just
right?
give me the
Here's the
50K.
cost. Here's how much money we're blowing out the window. And do you remember that energy crisis last winter?
Yeah.
This is what our peak power bill was to run this equipment for 1 month, right? Just put it all in an Excel sheet and it'll make sense for your oldest junk. It's really that simple.
Thank you.
I mean, it's not a whole solution, but
yeah. I mean, if there were an easy one fits all solution, hopefully we'll have it.
Maria, developer of Bird, you almost know what I am going to speak about. Yes, the sustainable practice we are trying and apply. We are already trying and applying is running things in the multiple threads, utilizing the CPU completely. Because, well, running the CPU on one thread, it's not 1/24 of wattage or 1/64 of wattage. It's almost it's not proportional. So yes, this is it.
Thank you.
Hello, Valerie Aurora, Frameshift Consulting. I have a question for the rest of the audience as well. Did you or anyone you know get promoted for saving money or increasing sustainability? If you made that spreadsheet, if you saved your company twice the value of your salary, did you get promoted or anything like that?
A nice tap on the back, maybe.
It's an interesting question. Promotion, no. But the KPIs you have normally say that you must be cost effective. And you can have it in different ways. You can go with more customers, or you can lower the costs for the operation of the equipment. So both can be good for your KPI and for the bonus at the end of the year. Promotion, no.
Sebastian, DT again. No, to the point, because yes, we do have a department that takes care about that, and that are the KPIs to lower cost at energy consumption, for instance. And obviously, the point we also do, at least in the network part, I know out of my engineering career, it's exactly we swapping out devices because they are more efficient, they can be utilized higher, can transport more gear, and we anyway operate at many boxes at the very high end, what's available basically. So we are first adopters of many of the big routers. So you have limited options to go there, but energy consumption is obviously one of them to save costs there.
Thank you.
Hello, Lorenzo from Topics again. I think one of the drivers that at least BoF has to go with a more effective way of, and also reducing the cost, is bound to cost themselves. So basically, besides the sites we managed, we were hosted at a co-location in huge data centers, and during the energy increases that have been during the last few years, they started billing as direct consumption for device, right? Or at least for rack. While previously was just in the fee, you just colo fee, there was also 3 kilowatts supply, for instance, right? So this shift brought us understanding also how much this impacted on our economics. And I think that if most of data centers and colo providers would shift towards this direction, even though it's costly because you have to do measurements, you have to, have meters and so on and so forth, this will probably be a huge driver also to change the chassis devices to more effective one, actually.
Sebastian again. Maybe not to paint it all black into the direction of the question, do we get promoted? If people outside of their original job doing that, obviously if they are good, maybe they can get a raise in the salary, but we do have internal programs. If someone has a very good idea, basically about whatever, that brings us money or saves us a lot of money, you get something, but it's maybe not a promotion.
Something sounds good then, better than nothing, right? All right. So we only have a couple minutes left to wrap up, and I don't want to be the one thing between you and Pasta. So I just want to wrap up quickly. If you have like things that jump to your mind about do's and don'ts about trying to make collaboration between academia and different part of the industry world, will be very much welcome. If we don't have time, I'm easy to find. You can write me or talk to me later as well. Yes, please.
Sebastian again? Yes.
So you have good and bad experiences? You have good experiences. Okay. So, all right.
Does it count that we are leading 2 bachelor theses?
2 what?
Bachelor theses.
It does, I guess. No.
It's also about getting things more efficient. So I think it fits in.
So I don't know how many of you have been involved with academic collaborations in the past, but what I can tell you from my not so long experience talking with students is that since 2 years now, we have a sustainable networking research page on our group website, and I'm now getting a lot more requests from interested students that want to try and do some work in this area, that want to get it to learn a bit better and try to educate themselves and contribute. So there is demand, and the students of today are going to be the employees of tomorrow. So if you are in an institution that is interested into hosting students that do projects or internships, there is demand. At least in Switzerland, there is high demand for interesting projects in this area.
One comment on it. I like the idea to have the students going into the companies, but maybe start first with IEEE, because they do the standards for Ethernet.
Yes.
You mentioned Ethernet multiple times this day. So why not work there with the people who actually make standards? I think the copper stuff sucks lots of power in every equipment which uses it. So why not go there? Your idea with switching things off and on, go there and maybe report.
We do actually. So it's a very good, it's a good advice, and we do this. But I don't only talk to network operators on my day-to-day job, but we do. We have contacts at IEEE and with the ATF as well that look at different aspects of things. So I guess most of you will be familiar with the energy efficient Ethernet standard, and there's been initial impulse to try to translate those paradigms to optical networks when optical networks started to be a real thing. And from what I understand, nobody found a way to really make it work. And so it doesn't mean we should stop trying. But if you have some good ideas about how to make the standard itself more energy efficient, I will be happy to hear out ideas and explore them. All right.
I guess I could give you one, which is sort of coincidentally slightly more energy efficient, but it's not exactly like, sorry, it's not exactly the most optimized thing, which is that several of the cloud builders are looking at, like, as more and more of the Ethernet stack goes to coherent modulation, um, variable speed Ethernet.
Yeah.
But I mean, it does use a little bit less power, but it's like teeny, this is the last thing you want to, I mean, it's there for other reasons, and it happens to use a little bit less juice, but the fact is that optical bandwidth is not a huge consumer of electricity.
Yeah.
The driver has a lot more to do with like the silicon node of the chip that's doing the stuff.
That's also the
what I will
understanding.
say that's really interesting, that's kind of going in the other direction, is like silicon photonics is becoming a thing, and it's actually way, we haven't made photonics in silicon before because it's not anywhere near as efficient as using indium gallium arsenide or any of the typical optical production processes, but there are other reasons to do it, right? And if you can use a less efficient transceiver to make the whole system more
better,
efficient,
it's
right?
a net
Because
gain.
Hyperscalers wouldn't be doing this if it increased their power bill.
Definitely.
Guarantee
No,
that,
definitely,
right?
yeah.
So it's an interesting thing to look at.
Sebastian, DT again. And maybe don't look just on the network or your actual direct working responsibility, but look around what you can do. Even switching off light in a room that's not used is a nice thing.
So I don't know how many of you were there at the last Friday meeting, but there was this presentation I mentioned earlier today where the presenter, Peter, I think, was making this case that, if you just count the number of LEDs that are light up all the time in a data center where we almost never need them because it's just for like debugging its setup, it's kind of like these little teeny tiny milliwatts of whatever, but it adds up, and it adds up to something that is negligible for the data center, but it adds up and it becomes meaningful in the grand scheme of things if the cost of turning this off is also kind of like zero.
Regarding that networking thingies, that chips, these are typically closed hardware. You have to push there a closed firmware, a complete blob, which you don't know anything about the sustainability, which you don't know anything about the effectivity. So this is just a call for looking for open hardware and trying to have less vendor lock-in and more openness to have competing softwares, competing firmwares for the same chips. Thank you.
Thanks for making that point.
Very good point, by the way. Very good point. What I wanted to say, there's already a switch window I know. We actually have an infrared sensor inside. So if somebody moves in front of it as a motion detector, it switches on all the LEDs. As soon as you're gone 2 minutes later, everything's dark again.
Nice, perfect.
I'm not sure. I think it was a BGT. There's some switches can do the trick.
Yeah. Yeah, this kind of, I was about to say, it's kind of like the easiest thing possible. You just put a switch on the power of the LED, since it's like the most. Yeah, it's exactly what I meant. I think it's the simplest thing you can think of, and the probably least energy efficient. Pure, good old style mechanical switch. All right, we're slightly out of time already, but we started late. So I would like to very much thank everybody for their contribution and their interests. You know how to find me. I'm easy to find. My name is all over the place on the program today. So please reach out if you want to talk more. Thank you for your inputs in the form and in person and online. I will see you in the rest of the meeting. I'm sure I am now. Anyway.